Okay, great. Our next speaker is Bimba Rao from Siemens Healthineers, and her talk today is entitled Advancements at Siemens Healthineers in AI for Medical Imaging. Please welcome Bimba Rao.
All right, can you hear me okay? All right, well, thank you for coming and listening. So I work at Siemens Healthineers. I heard someone else say they're from Siemens, so great to see colleagues here as well. So Siemens Healthineers, for those who don't know, is a Siemens healthcare company. We split off from Siemens about 2 years ago, 2.5 years ago, as an independent company that IPO'd. We build healthcare products in all areas. Medical imaging is a space that I work in, and that's what I'll be talking about. But Siemens has solutions in lab diagnostics, therapeutics, and with the recent Corindus acquisition in robotic surgery as well. So, all right. So, give you a quick glimpse of what's so great about Siemens Healthineers, right? Why would healthcare providers want to team up with us? We have more than 48,000 employees in more than 70 countries worldwide, so we are a huge establishment. We know what we are doing in terms of healthcare. We are the world market leader in most of our businesses and the market leader in most countries. With 13.8 billion euros in revenue, we are one of the 5 largest medtech companies in the world. We believe that transformational challenges will make it possible to increase value. We believe the future of healthcare, given today's market dynamics, will reflect the following. Medicine will be more precise and affordable. You've heard a lot of talks about precision medicine the last few days. And value will be at the heart of care delivery. Patients will be treated as consumers, not just healthcare providers. And healthcare will become digital. And we want to enable healthcare providers increase value through the entire continuum of care in terms of expanding precision medicine, transforming care delivery, improving the patient experience, and of course, digitalizing healthcare. So this is our main motto at Siemens Healthineers. We want to enable better outcomes while lowering the cost of care for our consumers. To ensure we provide the right solutions to our consumers, we want to make sure we understand the challenges and struggles the healthcare industry is facing today. Diagnostic and treatment programs are often designed for a one-size-fits-all, hence the need for going more towards personalized medicine and precision medicine. Health systems are fragmented. That really results in low productivity and variability across the care. Patients are not actively engaged in their healthcare. And we will see that changing more and more with wearables, information from wearables being integrated into the healthcare system. Healthcare is practiced based on fragmented information from siloed data pools, and hence we really are focused on integrating all possible patient information, and I'll talk a little bit more about that in a little bit. So what are the providers' needs today, right? Our healthcare provider wants low-cost preventative care, fast, accurate diagnosis, fast patient throughput, and everyone is asking for precision and personalized treatment, and we are committed to deliver that. With AI-powered application, we can move from having unwarranted measurement variability to expanding precision. We can move from repetitive stress to complete exams to transforming care delivery with increasing productivity and reduced stress through AI-powered automation. And lastly, we can move from the ever-increasing patient wait lists for medical exams to improving the patient experience through exam workflow improvements, and ideally less unnecessary interventions by reducing measurement variability. This is all powered by AI. to enable the precision that healthcare providers and their patients require. Again, a quick glimpse at where we are at Siemens in terms of artificial intelligence. We at Siemens Healthineers partner with several healthcare institutions throughout the world to curate and gather data sets through collaborations. With our global footprint and expertise in artificial intelligence and data scientists, we have more than 30 AI-enriched offerings with over 400 patents in machine learning and 100 in deep learning alone. Together, with everyone's help, our future is bright in artificial intelligence. So since data plays such an important role, it's important to organize our thinking of AI based on different levels of data consumption. At the first or bottom level, we have what we call the data generation, our scanners and instruments, CT, MR, ultrasound. These are all generating medical images and data. And AI contributes here to workflow automation and faster acquisition and reconstruction. The next level involves the immediate use of data, such as systems for reading, reporting, or guidance in the operating room. One level up, the complexity increases, data being integrated around the patient. This is the level for predicting, planning, and prescribing the right treatment at the right time for the individual patient. That is precision medicine. In this context, we focus not only on statistical models, but also mechanistic, physiological models, meaning the digital twin. And I'll get into digital twin a little bit more later. At the very top level involves the analysis of patient cohorts related to patient population health, outcome analysis, and meaningful use. So we can think of AI-supported systems as broken up into 5 levels, just as with autonomous driving and self-driving cars. At the very basic, you can think of AI as or automation as providing very basic general assistance to the user. And going on from there, it gets more and more automated. So going from partial automation, conditional automation, to high automation, all the way to someday we will see systems that are fully automated. We believe that the current technology is in the 2 orange buckets, partial and conditional automation, moving more and more towards the higher buckets as time goes by. So Siemens has several solutions in the partial and conditional automation space already in the clinical routine. Siemens Healthineers has been working on AI and AI-powered solutions before AI was even a thing or a big buzzword. So we have more than 40 AI-powered applications across various modalities and therapy solutions. And we believe that there's about 240,000 patient touch points per hour with our solutions. So here's an example of a conditional automation solution released by Siemens recently. It's called the FAST integrated workflow for CT scanners, where the CT scanner automatically adjusts to an individual situation by providing the right dose modulation, the right scan direction, and correct and complete body region. So we are at Siemens, and as an industry as a whole, I'm sure, stepping into the high automation region with the medical solutions we provide. And the AI Rad Companion is a great example of a high automation system. So if some of you might already be familiar with the AI Rad Companion. If you're not, the AI Rad Companion works with DICOM data and is compatible with systems across all vendors. In contrast to other providers that provide single applications for select organs, AI Rad Companion applications usually process several organs at once, saving you unnecessary workflow steps and giving you findings that might have been overlooked otherwise. So it's a complete integrated solution that looks at all patient data from all modalities, all possible forms of interrogation. So I work, and I have worked in ultrasound imaging for many years, so it's very near and dear to my heart. So I want to spend a couple of minutes talking about giving you an overview of AI-powered solutions that Siemens Healthineers provides in the area of ultrasound imaging. So these are videos, so I'm just waiting for the last one to start loading. So, all right, so AI, when people talk about AI, they're usually talking a lot about glamorous solutions, like, oh, we're going to diagnose all of cancer. That's where AI is going to be. It's going to get rid of all radiologists, right? But where I believe AI is really going to have impact is in chipping away at small, mundane, tedious, repetitive tasks that healthcare providers have to go through every day. And if there are any ultrasound technicians in the room, I'm sure they'll attest to the fact that ultrasound is one of the most tedious modalities there is for using and producing the right images that are required. So with that in mind, we at Siemens have been working diligently for over 20 years now in providing automation solutions to help eliminate the tediousness of doing an ultrasound exam. So easy measure, as you can see on the far left, it automatically recognizes the anatomic view and performs the measurements that are required by an ultrasound technician to be done in a standard echo exam. Easy Left Heart is an automated analysis package that automatically calculates the volume of the left ventricle, left atrium in end systole and diastole, and gives you ejection fractions and other required analysis measurements. Easy LVA does the same, but it uses a full volume ultrasound image. Easy PISA calculates your PISA volume from a color Doppler image. Easy Valves is something we have been really excited about. It actually uses deep learning to produce models of your heart valve. And this is exciting because this information can now be used in preoperative environments for doctors and interventionalists to perhaps maybe do a 3D printout of a patient's valve and test whether a device they are planning to deploy to repair the valve or replace the valve is going to fit, is going to work well, before even taking the patient into an operating room. So that's huge. So this is just the beginning of what we can do with AI and modeling of human organs. So delving a little bit more into our easy measure solution. So in limited studies we have done, we found that it significantly improved the quality and workflow efficiency of an ultrasound exam. And in addition to that, it reduced the intravariability, user-to-user variation. So as humans, we all, even for the same person doing the same exam, you will see variations in the measurements they might perform during the course of the day, because there's fatigue, there's tiredness, stress. Focus can vary from morning to evening. But thankfully, the machine will not be affected by those human factors. And it may not seem like a big number, but we found that just with automating the measurements alone, we were able to save about 6 minutes per routine echo exam. But what's more significant is we measured that the 6 minutes translates to about 200 keystrokes. So imagine the stress that ultrasound technician goes through pressing buttons on the system console 200 times per exam, and they do about 8 to 10 exams a day. So if you add all that up during the course of a day, during the course of a week, it's pretty significant what AI and automation can do to improve the quality of life of the healthcare provider and ultimately of the patient themselves. So easy measure is just not another automated measurement. It does use AI to take in expertly traced, measured B mode, M mode, spectral Doppler data sets, and it trains the application to detect landmarks and ultimately produce accurate tracings and measurements over 1 to 3 heartbeats. And it reduces hand movements by about 30%. So again, I just want to highlight this because I do believe that this is an area where AI is really going to have a big impact in the healthcare industry in reducing and getting rid of tedious and mundane workflows, procedure steps that need to be done in order to ultimately lead to patient diagnosis and care. So I just want to stress that the AI solutions that Siemens Healthineers offers spans across the entire continuum of care that the healthcare provider delivers. So all the way from diagnostic applications to therapy planning and guidance and in follow-up care for the patients as well. So I want to leave you with a quick glimpse into the future and talk about the digital twin. So it's hard for me to predict how much into the future, but I do believe that this is where we are headed as an industry with AI, especially with AI, is we want to move towards what we call a digital twin. And a digital twin is not a term that was coined in the healthcare industry. It has been around in the automotive industry for many years, in fact, where digital twins are models of machines or cars that are being developed that reside in software in the computer. And the model has all the information that is needed to build and perturb the model, be it a machine, and in this case, let's say it's a human organ. So if you can think of a digital twin of yourself, or if you want to start with your heart, say, since your birth, if we have been able to collect your information, your genetic history, your physiological data, your health habits, your eating habits, imagine all that information gets fed into this very big smart computer that now builds a computational model of your heart. And that heart model is being updated as changes to your life occur, such as aging even. What would be really cool is if that information is all correct, accurate, and complete, that model can then be perturbed to predict, let's say, what's going to happen to your heart in 10 years. What's going to happen to your heart if you start eating at McDonald's every day for the next 5 years? Or what could happen to your heart in the next few years given your genetic history or history of heart problems you've had in the family. So this can be used to actually provide an accurate predictive estimate of your health, because that's really where we want to be as humanity. We want to be able to predict disease before it occurs. We want to do diagnosis and treatment, but wouldn't it be much better if we were able to prevent disease in the first place? And that's kind of the idea behind the digital twin. It's a very ambitious project, and it's not easy. and it's going to take a long time to be successful and accurate, because even we don't know even today what information we might be missing in producing a complete model of the human body. But that's where we want to go. So our VP of R&D, Dorin Comanici, volunteered to have a digital avatar of himself created. So that's him over there, to give you an idea of what a digital twin might look like and what we might want to do. So where do we want to go from here, right? Imagine at some point in the future, our data is being integrated from birth through a lifelong physiological model that is updated with each scan and exam. And specifically, designed neural networks are analyzing the data continuously. As a result, we don't talk only about disease care, but we talk about health care, person-centric prevention. When disease happens, we have the right tools to establish the correct diagnosis and select the best treatment. For me as a person, the digital twin helps towards a healthier lifestyle. As a patient, I hope that it helps clinicians in selecting the best treatment and care for the patient. So that's the image I want to leave you with where we think healthcare delivery is going to be going in the future. And to summarize, that's just the beginning of technology driving efficiency and productivity, AI-driven outcomes that matter to patients, and software agents that help expand precision medicine. All right, I think I finished ahead of time. Well, thank you, everyone, for listening. Yeah, no, that's a good question, and that's the decision we as a healthcare community and we as humanity need to make. You don't want to subject a 10-year-old child to a CT scan, for example, right? But where we do want to see healthcare going is whatever information is collected on humans does enter this common database, because right now it's all fragmented, right? You go get a flu shot somewhere. We are all born with a genetic history, but that information isn't available to us necessarily, or isn't even in some database that we can harness and make use of to be able to predict. And then the question is whether we really want to do more in scanning, more blood tests, just so we can have that information. That's a balance we need to decide how worth that is. Thank you.
Right. Thank you very much.